Hello everyone. Today we are going to continue with our last session. In our last two sessions we have started carbon and nitrogen from 8th class toppers program. So in carbon and nitrogen we have completed single correct and conceptual understanding questions, passage type questions, multi correct answer type questions we have completed in the previous two sessions. So on this topic, today we are going to continue with the matrix matching type questions and analytical approach type questions. Okay, let us start our session with the matrix matching type in chemistry of carbon and nitrogen from 8th class toppers JEE NEET foundation. Okay, see matrix match type. See what is the matrix is given here. Here given two columns. In the first column they given about the graphite, charcoal, carbon dioxide, carbon monoxide, and this side what they for uses of those they have given here. Okay, let us check and let's match the with column 1 with column 2. Graphite. In the given A, B, C, D, E options, which one is correct about the graphite? We have to pick up that correct answer for graphite. Used as electrodes. Yes, we have a graphite electrodes. While doing electrolysis, we use the electrodes belongs to graphite. Graphite is used as the electrodes also. So, A is correct for graphite. Comes to the next one, used for fire extinguishing. Graphite will not, they will never use for the fire extinguishing. Comes to the C option, poisonous oxide of carbon. No, graphite is one of the crystalline allotrope of carbon and it is not at all the poisonous. Okay, so not even C option. Good conductor of electricity. Yes, graphite is the good conductor of electricity. Why it is good conductor means based on its structure there is one free electron. Because of the mobility of the free electron in that structure it generates the electricity. Then we can say graphite is the good conductor of electricity. Diamond is also the allotrope of carbon, but diamond don't have any free electrons in that structure, so it does not conduct the electricity. Here graphite is given, it is a good conductor of electricity, so D is also correct for graphite. And E option is used to decoloring sugar cane juice. Graphite will not use for decolorization of sugar cane juice. Okay, for then which one will use? If you keep some charcoal in the sugar cane juice, that charcoal makes decolorizing this sugar cane juice. So here 43-bit charcoal, this charcoal can use to decoloring the sugar cane juice. So for the charcoal, E is correct. Charcoal is used for this purpose, not for the charcoal will not use as electrode. Charcoal is also another form of the carbon, but in this form, in charcoal form, we will not use the electrode like. Okay, and used for fire extinguishing. Charcoal will not use for fire extinguishing, and also it is not a poisonous gas also, and charcoal is not the good conductor of electricity. Okay, now carbon dioxide. Already we know carbon dioxide. Carbon dioxide is the used for fire extinguishing. See here, these are the electrodes of graphite, like that only it is the we will have these cylinders, carbon dioxide cylinders at the extinguishing. So if any fire accident or anything happens, so if you observe in the shopping malls or in a theaters, complexes, if you observe, they'll keep an extinguisher and urgent extinguisher like. So there they'll keep the carbon dioxide cylinders. If any fire accident is occurs, we'll use as the fire extinguishing. So carbon dioxide is for fire extinguishing. We'll go with the B option. Carbon monoxide. Carbon monoxide will not use as electrode and it is not used as the fire extinguisher. Carbon dioxide will use as the fire extinguisher. Carbon monoxide is a poisonous gas. Already this topic we discussed in the previous session. Carbon monoxide is a poisonous gas like. See, carbon monoxide, if you inhale that or if you observe that, we cannot be seen, can't be smell, can't be hear. Our ears also will not work. So it is a poisonous gas. We are not supposed to inhale. If we inhale, it reaches to our lungs, it affects our eyes, it affects our throat, it affects our ear, it gives some disabledness. So carbon monoxide is a poisonous oxide of carbon. So we will go with the C option. The any remaining options are not correct towards the carbon monoxide. So this is the matrix matching for the given one. Come to the next one. It is another matrix match type. So here they given two columns like before. In this they given aqua regia, brown ring, ammonium fertilizer, calcium hydrogen carbonate. So this side they given some formulas. So we have to match for which one which formulas are correct like. See here aqua regia. Already aqua regia we discussed, that is the 1:3 ratio of HNO3 and HCl, right? So where is that? See in the D option we have HNO3 and HCl. This is the combination of aqua regia. So we will go aqua regia means D option. FeSO4NO. Aqua regia is not at all related to FeSO4NO and CaHCO3 carbon hydrogen carbonate is also not related to aqua regia. Ammonium phosphate, no, ammonium sulfate. So aqua regia only D option is correct. Even in matrix matching also multi correct it can be. That's why I am checking each and every option here. Comes to the brown ring. We have to discuss about this brown ring. While doing the experiment in the laboratory, here combination of H2SO4 and HNO3, and we have to add to this H2SO4 means you have to take one test tube. In that test tube you have to add H2SO4 and you have to add HNO3 by keeping in the inclined position. Then if you add freshly prepared FeSO4, freshly prepared, we have to prepare that FeSO4 solution instantly. To get this brown ring, we have to use freshly prepared only. When you are keeping in the inclined position, exactly you can observe in this figure, here between the two layers of HNO3 and H2SO4, they will not combine. Those are immiscible liquids. Those two immiscible liquids between, there will be a brown ring we can observe. What is the formula of that brown ring is our question now. See the reaction here. Freshly prepared FeSO4 is mixed with H2SO4 and HNO3. It forms FeSO4NO. This is called nitrosoferrous sulfate. That brown ring formula is the nitrosoferrous sulfate, means A option. For brown ring formula is FeSO4NO. Here dot should be there. So A option. The remaining any formula will not match with the brown ring. Only A option is correct for the brown ring. Next come to the ammonia fertilizer. All the ammonium salts we can use as the fertilizers. So in the given options, where do we have that ammonium salts? First one is nitrosoferrous sulfate, second one is bicarbonate of calcium. Ammonium phosphate. Ammonium phosphate will use as the ammonium fertilizer because it is a ammonium salt. And D option is the mixture of aqua regia. So D will not come for ammonium fertilizer. Come to the E option, ammonium sulfate. This is also ammonium salt which we use as the ammonium fertilizer. So C and E both are correct for 48. Okay. Comes to the next one, calcium hydrogen carbonate. This is the bicarbonate of calcium. CaHCO3 taken twice will go with the B option. So this side they given the molecules and they asked to match with their molecular formula. So this is the matching: aqua regia, HNO3 and HCl, brown ring, nitrosoferrous sulfate, ammonium fertilizer, ammonium phosphate, ammonium sulfate will come. Calcium hydrogen carbonate formula is CaHCO3 taken twice. Okay, it is clear, right? Comes to the next one. Already we completed two matrix matching type questions, right? Comes to the statement type question. What is this statement type? They'll give two statements. We have to identify either both the statements are correct or one statement is correct or another statement is wrong, like that. Let us see the first question in that. So these are the options. Generally in statement type questions, these options are fixed. A option will be both statements are correct, B option both statements are incorrect, C statement 1 correct, statement 2 incorrect, D option statement 1 is incorrect, statement 2 is correct. Let us see what are those statement 1 and 2. In statement 1 they given freshly prepared nitric acid is colorless. Statement 2 is the yellow color of nitric acid is due to the formation of NO2. Yes. See, freshly prepared nitric acid will be colorless. It is like a plain water like. It is an acid. It has a fumes. Concentrated nitric acid has fumes and diluted nitric acid has no fumes. We can touch with our hand. That depends upon how much you are diluted that acid, right? So, what it is freshly prepared, immediately if you are after preparing the HNO3, if you observe that color of HNO3 is colorless, this statement is correct. You can observe in this picture here. So in this picture we are preparing the nitric acid by using concentrated sulfuric acid and potassium nitrate. On heating this one, we are getting nitric acid as a gas and we are collecting that one into the round bottom flask. If you observe here, the color of nitric acid is colorless. So statement 1 is correct. Comes to the next statement, the yellow color of nitric acid is due to the formation of nitrogen dioxide. Freshly prepared one is colorless, but if you store that nitric acid for some time, after 2 hours or 3 hours, after 24 hours, after some time, after 1 day, if after some time, if you observe, not freshly prepared, not immediately prepared one, after some time, immediately this colorless one turns into the yellow color. See, in this bottle it is stored. If you observe here, it is colorless. In this bottle it is stored. The stored HNO3 is yellow in color. Why it is getting this color? Due to the formation of nitrogen dioxide. Yes, the reason is correct. Means statement 2 is correct. Both statement 1 and statement 2 are correct. We will go with the A option. Why this nitric acid turning color? Due to the nitrogen dioxide formation. By passing the time, this nitrogen dioxide will form. Because of that reason, that colorless solution is turning into, colorless acid is turning into yellow color. Okay, comes to the next one. So this is statement type. Now we are going to analytical approach type questions. Okay, start with the first question in analytical approach type. First question, by mass what is the relative abundance of carbon in the universe? In this chapter, in our first session, we have the question, what is the percentage of abundance of carbon? Carbon is the in which position for abundancy in human body? In human body, if you observe, carbon is the second most abundant element. Okay, first one will be oxygen. Here the question, by mass, what is the relative abundance of carbon in the universe? Overall universe is considered, what is the position of carbon? Okay, see here in this picture it is clear. Hydrogen is 73.9%. The most abundant element in the universe is hydrogen. Helium is 24%. Second one is helium, 24%. Oxygen is 1%. See here the 1%. Here you can observe the color difference also. Carbon, the fourth abundant element, is 0.5%. Next, neon, iron, nitrogen, remaining all they will have 0.3%. So carbon is the most abundant element. No, because most abundant element is hydrogen. Carbon is second most abundant element. No, second most abundant element is helium. So B option is also wrong. Carbon is the third most abundant element. It is clear the third most abundant element in the universe is oxygen. So C option is also wrong. Carbon is the fourth most abundant element. Yes, with 0.5%, carbon is the fourth most abundant element in the universe. Okay, comes to the next question. Dry ice is composed of, we know this question, dry ice is nothing but solid CO2. Carbon dioxide is a gas. If you convert that into the solid, this solid CO2 we call as the dry ice. That looks like this. You can see in the picture, the dry ice will be like this, solid form of carbon dioxide. So the given options are solid hydrogen, no; solid oxygen, no; solid carbon monoxide, no; carbon monoxide is poisonous. So solid CO2, we'll go with the D option. Okay. Next question. Which of the following statement is not correct about nitrogen? Which is not correct? In the given 4 options, which one is not correct regarding nitrogen, we have to find out. Let us see with the first option. Nitrogen has 5 electrons in its valence shell. Yes. What is the atomic number of nitrogen? Nitrogen's atomic number is 7 and its electronic configuration is K shell, L shell. In K shell 2 electrons, L shell it has 5 electrons, right? So last shell is the L shell, that is called valence shell, right, or outermost shell. The number of electrons present in the outermost shell are called outermost electrons or valence electrons. So according to this atomic number and this K element shell, 5 electrons in its valence shell is correct. So first option is correct. But in the question they asked which is not correct. So not the first option. Second option, nitrogen forms acidic nitrogen dioxide on burning in oxygen. Yes, because while discussing about carbon we clearly said carbon is non-metal. Always the non-metallic oxides are acidic in nature. Here nitrogen is also non-metal. When nitrogen is combining with oxygen and forms nitrogen oxides, non-metallic oxides, all non-metallic oxides are acidic in nature. So the statement nitrogen forms acidic nitrogen dioxide on burning in oxygen, this is correct statement, correct only, acidic nitrogen dioxide only will form. But he is asking not correct, that's why this option also will not come. See, nitrogen is most abundant element in the universe. No, not the nitrogen. Oxygen, hydrogen, most abundant element in the universe is hydrogen, helium. Just before in the previous question we discussed nitrogen in actually in the last place, 8th place nitrogen. He said most abundant. So it is the wrong statement which is correct for our question. He asked to find out not correct. So C option is not correct. That will be the answer for this question. Let's take D option also. Nitrogen is the first element of nitrogen family. Yes, nitrogen family means 5th group elements. 5th group elements are nitrogen, phosphorus, arsenic, antimony and bismuth. So these are the nitrogen family and in that first one is the nitrogen. Okay, so the option is also correct but not comes to this answer. So C will be the correct. Now let's go to the next question. N2 plus 3H2 gives A. What is A in the equation? This one in the previous session while discussing about Haber's process we completed this reaction. Nitrogen reacting with hydrogen under high temperature, high pressure and iron is using as the catalyst forming NH3 means ammonia. Let us see in the options. NH3 is also there, 2NH3 is also there. We have to balance the equation. 1 mole of nitrogen reacting with 3 moles of hydrogen produces 2 moles of ammonia. So 2 moles. In the first option given 1 mole. Second option given 2 moles. So we will go with the B option, 2 moles, not the first option. NH3 is correct but number of moles are wrong. That's why we are not taking the first option. Comes to the C, N2H6. No. Here you can observe clearly the Haber's process. N2 plus 3H2 gives 2NH3. It is a reversible reaction, means from ammonia we can get back nitrogen and hydrogen in a closed vessel. Okay, it is a reversible reaction in a closed vessel because the reactants and products both are gases. If you consider this reaction in a open vessel, that is irreversible reaction. If you taken this experiment in the closed vessel container, then it is a reversible reaction, okay, and not N3H also. NH3 wrong, this is NH3. Even if you consider this is as NH3, it is 1 mole. So not 1 mole, 2 moles, 2 NH3 is required. So we will not go with the D option. So correct option is NH3 Haber's process. Next one, animals die in the atmosphere of nitrogen due to, when there is a high amount of nitrogen, there is a suffocation because there is no oxygen will be present. Oxygen, no oxygen. It's a poisonous nature, not the poisonous. Because of that poisonous nature, animals are not dying. There is no poisonous nature. There is a suffocation. There is the absence of oxygen. Okay, not the poisonousness. Animals die in the atmosphere of nitrogen due to the absence of oxygen. Okay, so our first option is its poisonous nature. No. Next one, as absence of oxygen. Yes, because of the absence of oxygen they will die. Not for the nitrogen, it does not have any poisonous nature. Okay, and its acidic nature. No. And its highly reactive nature. No, not all these reasons, they will not affect the animals till death. The remaining 3 options will not be reasons for the death of the animals in the presence of nitrogen. Because the only reason is, even in the atmospheric nitrogen also, because of absence of oxygen the animals will die. Okay. Comes to the next question. Most harmful effects of acid rain is on. Because of this acid rain, who is affecting mostly is our question. See, actually because of this acid rain, mostly plants are affecting and aquatic animals are affecting. Aquatic animals which lives in the water, fishes, all those are affecting. See, in the options are aquatic plants, herbs, trees, all of above. Aquatic plants and as well as even animals also which are harmful. See here you can observe, because of the acid rain the greenery of the trees is gone, just they are dry trees like, and here you can observe the color how it turns. Yellowing of leaf tissue. This is also because of the acid rain. Here this is also aquatic life is affecting because of this acid rain. Even Taj Mahal also it turns to yellow because of the acid rain, because more pollution is presenting, right? So all of these are the correct answers for this question. So we will go with the D option. Okay. Next one, production of ammonia is. In Haber's process we are preparing the ammonia, and that production of ammonia is either exothermic reaction or endothermic reaction or ectothermic or hypothermic. These are the options. See here, while it is 2 types. N2 plus 3H2 gives 2NH3. It is a forward reaction, means N2 reacting with hydrogen and forming ammonia, formation of ammonia, production of ammonia, they will releases high amount of energy. Energy is releasing. The chemical reactions which releases energy, those are said to be exothermic reactions. If you observe here, because Haber's process is a reversible process, when from ammonia preparing nitrogen and hydrogen consumes energy, means it takes the energy. So it is endothermic in nature, it requires amount of energy. So it is endothermic in nature. But in our question, production of ammonia they said. So we have to take this reaction, while nitrogen reacting with hydrogen and forming ammonia, it gives out heat energy. So it considered as exothermic reaction, not endothermic. When it will be endothermic reaction, from ammonia you are preparing nitrogen and hydrogen, then that will be endothermic reaction. But our question is clear, we will go with the B option, not even ectothermic and not hypothermic reactions. Okay, let's see, we have completed carbon and nitrogen chapter in 8th class toppers program. Okay, please